Hello, friends. Disclaimer. As an Amazon associate, I earn from qualifying purchases at no additional cost to you. Please don't forget to check out product links for stargazing in the description of the video. The James Webb Space Telescope has once again proven to be a game changer in our quest to understand the cosmos. Imagine a world drifting alone in space, not orbiting any star, but instead wandering through the galaxy. These are rogue planets, mysterious objects with planet-like masses that defy traditional definitions of what a planet should be. And now, JWST has uncovered 6 of these rogue worlds in a young star-forming nebula located about 1,000 light-years away from Earth. These rogue worlds are unlike anything we've seen before, challenging the very definitions we use to classify planets and stars. What makes this discovery even more intriguing is that one of these rogue worlds is surrounded by a disk of space dust. This disk could potentially give birth to a miniature planetary system, a scaled-down version of our solar system, right in the heart of the galaxy. But how did these rogue worlds come to be? Are they the remnants of failed stars, or planets that were ejected from their systems? And what does their existence tell us about the hidden complexities of the universe? In this video, we'll explore these mysteries, diving into the latest groundbreaking discoveries made by the James Webb Space Telescope and uncovering what these rogue worlds reveal about the cosmos. Rogue worlds, also known as rogue planets or free-floating planets, are some of the most enigmatic objects in our galaxy. Unlike typical planets that orbit a star, rogue worlds wander through space untethered, drifting alone in the vastness of the cosmos. These mysterious objects have masses similar to planets, but they don't fit neatly into the categories we use to describe celestial bodies. They challenge our conventional understanding of what constitutes a planet or a star. So, what exactly are these rogue worlds? Imagine a planet-sized object, much like Jupiter or Saturn, but instead of circling a star, it floats freely through the galaxy. Scientists believe that rogue worlds could form in a couple of ways. One possibility is that they began life just like any other planet, coalescing from the dust and gas surrounding a young star. However, due to gravitational interactions with other planets or stars, they were flung out of their original solar system, doomed to drift through space alone, forever severed from their parent star. Another possibility is that rogue worlds could be failed stars. During the process of star formation, a cloud of gas and dust contracts under its own gravity. If the mass of this cloud is too small, it won't ignite nuclear fusion, the process that powers stars. Instead, this object remains a cool, dim body, essentially a large planet-sized object that never becomes a true star. These failed stars, sometimes referred to as sub-brown dwarfs, add to the diversity of celestial bodies in our galaxy. Rogue worlds challenge our understanding of planetary and stellar formation. They blur the lines between planets, brown dwarfs, and stars, making them incredibly fascinating for astronomers. Despite their elusive nature, rogue planets could be quite common in our galaxy. Recent studies suggest that there might be more rogue planets in the Milky Way than there are stars, making them an integral part of the galactic ecosystem. The James Webb Space Telescope has once again expanded the horizons of our understanding with its latest discovery. In a young star-forming region known as the NGC 1333 nebula, located about 1,000 light-years away, JWST has identified 6 new rogue worlds. These free-floating objects are each estimated to be between 5 and 10 times the mass of Jupiter, making them some of the most intriguing celestial bodies observed to date. These rogue planets are unique because they don't orbit any star but instead drift through space on their own, adding a layer of mystery to their origins. Among these 6 rogue worlds, the lightest one stands out as particularly fascinating. This object is surrounded by a disk of space dust, a feature typically associated with star formation. In the early stages of a star's life, dust and gas orbit the central object, gradually coalescing to form planets. However, in this case, the central object didn't have enough mass to trigger nuclear fusion, the process that powers stars. Instead, it remained a cold, dim body, a rogue planet. The presence of this dust disk suggests that this rogue world might be a miniature planetary system in the making, albeit on a much smaller scale than our solar system. This could be a rare opportunity for scientists to observe planetary formation in a context vastly different from what we see around stars. The discovery of these rogue worlds provides valuable insights into the diversity of celestial bodies in our galaxy. But JWST didn't stop there. The telescope also identified a new brown dwarf, a type of celestial object that is larger than a planet but smaller than a star. What makes this brown dwarf particularly interesting is that it has a companion, a rare planetary mass object. This duo likely formed through the same process that creates binary star systems, where a collapsing cloud of gas and dust fragments into two separate objects. Such a formation process challenges our understanding of how celestial pairs can develop, especially when one of the bodies is of such low mass. This discovery is significant because it blurs the lines between stars, planets, and brown dwarfs. Traditionally, celestial bodies have been categorized based on their mass and whether they undergo nuclear fusion. However, these new findings suggest that nature is far more creative and complex than our classifications can accommodate. The fact that these newly discovered objects are 5 to 10 times more massive than Jupiter indicates that they could have formed similarly to planets, from the disks of gas and dust surrounding young stars, before being ejected from their systems due to gravitational interactions. Alternatively, they might have formed through a process more akin to star formation, where a gas cloud collapses but fails to ignite fusion. These discoveries challenge existing models of star and planet formation, pushing scientists to refine their theories to account for the remarkable diversity of systems that JWST has revealed. As we continue to explore the universe, findings like these remind us that there is still so much we don't know, and that each new discovery opens up a world of possibilities. The JWST is not just revealing new objects, it is reshaping our understanding of the very processes that govern the birth and evolution of celestial bodies across the cosmos. The discoveries made by the James Webb Space Telescope in the NGC 1333 nebula have far-reaching implications for our understanding of how stars and planets form. Traditionally, our models of star and planet formation have been fairly straightforward. A cloud of gas and dust collapses under its own gravity, forming a star at its center, with planets forming from the surrounding material. However, the rogue worlds and the brown dwarf with its planetary mass companion discovered by JWST challenge these simplistic models. The presence of these rogue worlds, objects that are 5 to 10 times more massive than Jupiter, suggests that not all planets form within the comforting confines of a star system. Some of these objects may have formed as planets do from the disks of gas and dust that surround young stars, only to be later ejected from their systems by gravitational interactions. This scenario implies that planetary formation is a more chaotic process than previously thought, with gravitational forces playing a significant role in determining the ultimate fate of these bodies. Alternatively, some of these rogue worlds might have formed more like stars. If a collapsing gas cloud lacks the necessary mass to ignite nuclear fusion, it might still form a planet-sized object, a sub-brown dwarf, that wanders the galaxy alone. This formation process blurs the lines between what we traditionally classify as planets and stars, suggesting a continuum of formation mechanisms rather than distinct categories. The brown dwarf and its companion also provide critical insights. The fact that this pair likely formed through fragmentation of a collapsing cloud, similar to how binary star systems form, highlights the diversity of celestial formations. It pushes astronomers to reconsider how such low-mass objects can form in pairs, complicating our understanding of the processes at play in star-forming regions. These discoveries force us to refine our models of celestial formation. They show us that the universe is far more complex than our simple categories suggest, and that the processes leading to the formation of stars and planets are more varied and intricate than we ever imagined. The discoveries made by the James Webb Space Telescope are not just expanding our knowledge, they are reshaping it in ways we never imagined. The 6 rogue worlds and the brown dwarf with its planetary mass companion found in the NGC 1333 nebula challenge our understanding of how stars and planets form. These findings remind us that the universe is full of surprises, and with every new discovery, we open up more possibilities for exploration and understanding. If you're ready to take your stargazing experience to the next level, check out the telescope and binocular through the links in the video description below. As an Amazon associate, I earn from qualifying purchases, but it won't cost you a penny extra. As we continue to explore the cosmos, who knows what other mysteries await us? If you're fascinated by the wonders of the universe and eager to stay informed about the latest space discoveries, make sure to subscribe to our channel, like this video, and hit the notification bell so you don't miss any updates. Together, we'll continue to unlock the secrets of the cosmos and broaden our understanding of the universe.